Ron, thank you very much and welcome everybody to this YouTube live stream. Just a little bit of a way of introduction. I guess when Chris Tilley contacted me and said, okay, we'd love to have you at the BCS Hertfordshire, I was quite excited. And then I started to think, well, what am I going to talk about? Because my research background is I like to get involved in many different things. So I thought about whether I should talk about smart cities, and the likes of the work that we've done in Milton Keynes, or whether I should focus on the latest developments in terms of Facebook or Google. And then I actually settled on the field of artificial intelligence. And the reason for that is because I think it'll be an absolutely fantastic opportunity, not for me to wax lyrical about everything that I know about artificial intelligence, but just actually to spark some debate and hopefully some long-lasting connections where we can talk about artificial intelligence. And really what inspires me around artificial intelligence is not its applications and its history from the 1970s, but actually what it's applying today in terms of how it helps us identify and look at trends around things like Facebook and the way in which we can present material, but also to little devices like this, Amazon Alexa, I hope you can see that, through to things like this, smartwatches, all of which we can utilize in order to build upon artificial intelligence. But medicine in particular, especially given where we find ourselves today in the era of COVID-19, but also more widely in disease like cancer, we've really seen a proliferation of how artificial intelligence can really speed up drug trials, reducing it from, for example, 5 years right the way through now to about 12 months. Of course, that comes at a cost, and hopefully today will spark some lively debate about the benefits of artificial intelligence, but also what we might need to be wary of. So really the title of my talk is, what does it hold for our future? But before we get onto the future, let's take a little delve into artificial intelligence, because actually, yes, it started off in the 1950s as we know it in the field of computing and what then became computer science. But actually, more broadly, it has much deeper roots right the way back to the Byzantine era. But let us start off talking about, well, what is artificial intelligence? If we take the pure definition that you've got on screen in front of you there, it's about being a branch of computer science. And many of us who studied computer science at university in the 1970s right the way through to the late 1990s might be used to things like knowledge-based systems or decision support systems, or how artificial intelligence was there in order to help us play chess, and how mainframe computers and large supercomputers like Deep Blue and others have managed to beat humans at chess, and most recently being able to beat humans at Go. But put more simply, let's go back to the real roots of it. Can we actually build a device, in essence a computer, that can actually think for itself, that has emotions, and that can actually learn without being told what to do? And I think although we've made fantastic advances in artificial intelligence, we still very much are at the artificial intelligence stage. We as humans still have to tell the computer the rules that make up its world. Because first and foremost, computers are still, and this is probably a bit of a controversial statement, so I apologize, computers are stupid. At the moment, they can only do what we tell them. Of course, there have been advances and people have built software systems whereby, for example, Alexa can build up a knowledge base and can start to give you more guided advice. But about 5 years ago, I'm not sure. Oh, there we go. Technology. We have my Alexa going off there. About 5 years ago, I went to the annual Loebner Prize by Hugh Loebner, who sadly passed away since then, at Bletchley Park. And I was invited to be one of the judges, whereby we got together some of the world's best minds coming from across the UK and broader geographic regions. And we asked them to build a system, an agent-based system that could interface with humans. and we were in one room and they were in another. And yet every single solution that was put there could really be brought off the tracks and fail by asking very, very simple questions. So whilst we've come a long way since the 1970s, there are still many areas whereby we're still looking for that mantra of building a machine that is truly intelligent and that truly has and can show emotion. Now, back when I was a teenager, I read the book A Brave New World. And many of the things that I see today in terms of developments around artificial intelligence throw great parallels with that 1930 book, where we described a new world state where our citizens are, as it says here, environmentally engineered. I'm glad to say, at least not to my knowledge, we haven't yet got to that stage, but we have made great advances in the areas of artificial intelligence. And the things that are described in the novel here by Huxley, actually, some of those are things that still haven't actually been achieved when we think about artificial intelligence. We might draw parallels and start talking about, yes, well, I can see where an intelligence-based social hierarchy might be useful or might exist. But that was very much pie in the sky in the 1930s. And I'm glad to say we haven't followed the Brave New World as it was laid out by Huxley, but I think we have started to enter a brave new world. We've become much more dependent and much more at ease with technology. Most of you probably drive. Think about the technology and the brain and the computer that's in your car that can navigate you wherever you might need to go, that can tell you tire pressures, that can use sensors. And potentially now, if we think about some of the insurance companies, how that data can actually be used to make you a safer driver. Well, perhaps. So I guess my question, and it's probably something that will come up in the chat later on, is actually, can we create something that is artificially intelligent? And it's not without its challenges. Of course, we've got many great programmers out there who've built systems and program systems using techniques like artificial neural networks, which I'll say a little bit more about later. We've had biologically inspired models like genetic algorithms, cellular automata, and various other aspects. But actually, to build systems that are intelligent is hard, because actually, from a computational perspective, being able to describe what intelligence is difficult. There's no one easy model that everybody points to and says, oh, that's how we would define intelligence. And one other thing that I talked about earlier on that I think is really important is that ability for emotion. Because if we're going to build things that are artificially intelligent, there's one side to think about, that's great technology. So for example, machine learning and how Facebook is using artificial intelligence to help deliver content to users. And it's not the only one. But actually, if we want to have that concept of what intelligence is, there's something right up here in our heads that's far more powerful than any of the computers that have been built at the moment. And that's our brain. And actually being able to model the brain in a way that we can fit within a laptop, or the way in which we can fit within a desktop or a supercomputer, that isn't something that we've cracked at the moment. We really are getting closer, but actually no one has managed to create a computer that, at least in terms of the way humans interact with it, demonstrates artificial intelligence. So the real mantle of what we're trying to do when we're trying to build something that's artificially intelligent is that it's absolutely indistinguishable from a human being. And the limits of current computers, we've really come a long, long way. But the limits of computers are still there, and we're still not able to break them when it comes to human or artificial intelligence. The way in which questions are asked, that engagement when you just strike up a conversation about random things. Computers are not good at doing that. They need to have very, very clear sets of instructions. They need to have very, very clear rules. And so, whilst we take fields like machine learning, data analytics, big data, and all of the latest buzzwords, we're still falling short. Believe me, we really have made fantastic advances, and I'll pick up some of those in terms of medicine later on. But truly speaking, there's not one application that I can put my finger on where I can say, yeah, that's a truly artificial intelligent system that passes the Turing test, which is number one, that it's indistinguishable. Okay, so I couldn't tell it from a human. But actually, some of the things that computers do, the voices that computers have, the way in which they present information, to me at least, and I'm happy to be corrected, I'm happy to enter debate and discussion, I still don't feel like computers really are intelligent in the same way as we as human beings are. And there's one big reason for that. And the reason for that is the human brain, while small, okay, if you compare it to a supercomputer, is vastly more complex than any computer circuit that we can build in silicon. And that really started to inspire in the early 1990s models that were very much built around biocomputing. So there were lots of models out there that were wild and wacky around, for example, biological material being able to be used to build computers. And then came along quantum computers, and we are making vast and quick advances when we come to quantum computing. But still, the types of problems that those quantum computers can solve, they're still toy problems. They're still small problems if we think about it in the context of our brain. Every minute of every hour of every day, our brain is doing hundreds and thousands and millions of calculations. It's allowing us to talk, to think, to breathe, to make sure that we're not in danger. And it does that whether we're fully conscious or whether we're asleep at night. So I think artificial intelligence has a lot to offer, but I think perhaps we need to think differently about the applications where artificial intelligence is really going to have an impact. So it could be in assisted living, given that we have an aging population, for example, or it could be in developing new drugs and helping to cure cancer, or helping to spot the signs of cancer or other debilitating diseases early on in the process. And perhaps also to take in people's lifestyle and to be able to predict or to be able to advise whether their lifestyle might lead on the basis of the knowledge bank that that particularly artificial intelligent device has built up over days, months, or years. So we talked very briefly about AI. It has origins all the way back to Aristotle. And we can trace it back because a lot of the applications and the early applications of artificial intelligence were around pattern recognition, being able to determine similarities or differences in faces, in objects. And a lot of robotics and a lot of visual and graphical systems can make use of pattern recognition. So we can certainly say, in terms of manufacturing, in terms of, for example, the automobile industry, that artificial intelligence has had an impact. But if we think about where we've come from, we can go all the way through to Babbage and the difference engine that Babbage produced. And that was an example of one of the earliest practitioners of artificial intelligence. But it took a long time. Okay, we're talking about the 19th century. We didn't really get computers until Alan Turing. Yes, we had various different types and approaches. We had very theoretical models, but actually it wasn't until the 1940s that something really concrete that you and I would recognize as being a computer and something that we could help learn really started to come to the marketplace. And it was nearly another 20 years before the term artificial intelligence popped up. And it's really the father of artificial intelligence, John McCarthy, who mentioned that phrase in 1956. So to some of you, okay, from 1956 to today, you might say the field is relatively young. Yes, it is. But it's really only the last 10 years or so that we've seen significant advances in applications of artificial intelligence in real life. Before that, we saw a lot of artificial intelligence in ivory towers, in universities. So people built algorithms, they built neural networks like self-organizing maps, for example, and they applied those to very theoretical problems, which is nice. It creates good research. But for me, the real benefit of artificial intelligence is when it has an impact in the real world, in day-to-day life. So the real beginnings of artificial intelligence were around these neural networks, artificial models of the brain, where we could build those in software. And in fact, neural networks tend to be applied today in facial recognition systems. So if you pass through the airport, for example, and something is looking to see whether your face matches the face that is on your passport, there is an element of pattern recognition going on there. And if you're anything like me, when you try and go through those e-gates, I'm afraid it doesn't like me. It doesn't like my face. I always end up being rejected and having to go back to the queue. So to me, that's one of the biggest failures of artificial intelligence. But that's probably not being fair. That's probably because the photograph I have on my passport, the background is too pale, and therefore it's very difficult for the computer to be able to pick out the points it needs to measure in order to determine whether the photo it takes of me in real time matches the photo on my passport. But neural networks were really the first examples of artificial intelligence. They aimed to simulate the brain. They modeled themselves on the way in which the brain works, firing impulses through the network and then being able to use those in order to make decisions. And so, as I say, pattern recognition is an example of where neural networks have been used. But there are other examples. So there are examples of people who built chess and chess programs and chess games, whereby the computer can play against a human component. And artificial intelligence is utilized there on a regular basis. We might not know it, and we might argue whether it's real artificial intelligence or whether it's just a rule-based algorithm, whereby we choose all the possible moves and we weight each of those moves, give it a score, and then we choose the best score for our move. Because ultimately, that is what an artificial intelligence chess program does. It looks at the move that a player has made, it compares all the counter moves, and it chooses the one with the best score. Of course, that's all well and good, but we're not all chess players. We don't necessarily all go out there and work in a theoretical world. For many of you out there in the industry, you're probably saying, okay, well, actually, what are the applications of artificial intelligence in practice? How can it affect you and I? How can I get involved in artificial intelligence? Well, here's some examples. And of course, this is not an exhaustive list. You could probably go onto Google and you could probably find 100 more examples. I mentioned before the idea of data analytics, and I see a real opportunity for the data that we collect on a day-to-day basis. Okay, if you take the telemetry on a racing car, it creates gigabytes of data in a matter of a few seconds. But actually, could we use those data analytics to help us analyze social deprivation and help then put targeted programs of work in place. I'm not talking here about algorithms. I'm not talking about computers in terms of putting the options in place. But one thing computers are very good at is reviewing data and being able to do lots of sums very, very quickly and to be able to pick out patterns. So, for example, it could tell us, it could learn about things. It could make some interventions, for example, or suggest some interventions in particular areas of social deprivation. And then measure the impact that putting those in place actually has. And then it could make decisions and feedback. And that's where artificial intelligence, in my view, is most important. That feedback loop, that learning loop. And that's why you don't really necessarily hear the term artificial intelligence anymore. You're probably more likely to hear machine learning as a way or a term that's being used. Another area and a related area is that of big data, be it applied to the insurance industry, be it applied to smart cities, and being able to make interventions that improve or reduce congestion, reduce electricity usage, and reduce water usage, or more effective use of water usage, are just some of the examples and ways in which artificial intelligence, in my view, can be used. So you've probably heard data analytics, predictive analytics. What's going to happen? How can I learn? How can I feed in? How can I make things better? Other areas, targeted marketing. An example of that, recommender systems. So do you ever wonder why you go on, when you go onto Facebook, suddenly you get a whole load of things that are related to something you've searched on in the internet? Well, it's because Facebook is using your search history, is able to use your search history. Other things, many of you probably got Amazon accounts. If you've got Amazon accounts, they use something called a recommender system. And it uses your purchase history to recommend particular products that it thinks you might like. And it does that when you log in, but also if you choose a particular product, when you go in and you try and buy the product, you probably get presented with 10 alternatives, or users that bought this also bought these other 5 items. So we can use artificial intelligence to learn about our users. And actually, one of my PhD students, Mark Hooper, did a PhD on recommender systems. And what he realized was actually, yes, they have the basic artificial intelligence there. They have the ability to learn about somebody's search history. But what is missing from those solutions at the moment is an element of emotion, is an element of taking our environment into account in purchasing decisions. But that's a whole other talk. But what he did was he built a recommender system that took and gathered people's emotional state and information about their environment and use that to soften the marketing approach. Because I don't know whether you feel the same thing, but if I log onto my Facebook account or I log on to Amazon and I want to buy something, I tend to be quite specific in terms of what I want to buy. I'm not really interested in the other 10 or 20 different things, and I'm not particularly interested in very targeted marketing. I like to feel a bit of compassion, but maybe that's just me. Purchase recommendations, aviation. Interestingly enough, that there's a project going on at the moment whereby combat management systems and a software development kit has been made available, and how we can potentially start to look at solutions around artificial intelligence being applied to other areas. But to me, most importantly, I think medical diagnosis and cures and new drug discovery is the most exciting area in terms of being able to apply artificial intelligence. And the reason for that is because it affects people's lives very, very personally. And actually anything that can cure cancer, or any other debilitating disease, motor neuro disease, or any of the other diseases that are out there where we sadly haven't yet cracked that mantle, I think they really warrant applications of artificial intelligence and real effort. And what we're noticing now is a lot of research groups, a lot of industries are turning their attention to see how artificial intelligence can learn about diseases, learn about mutations, because quite often that data and that analysis and that trawling, it takes some time. So if you're looking at x-rays, if you're looking at blood samples, if you're looking at other physiological conditions, if you're doing that as a person, well, if we can take some of those aspects and we can speed those up, then we can hopefully eradicate or, at the very least, significantly reduce the impact that they're having on society at large. And there's a lot of work. I'm not suddenly carving out, for example, a new research field here. There's been a lot of work already that looks at how artificial intelligence can be utilized in cancer. And we're going to see some of that in a minute. So AI really is everywhere. We don't necessarily recognize it as being artificial intelligence. We probably think it's quite quirky. We probably think, how on earth or what on earth is that? Or we might be used to using different terms like market analysis or data analysis or data analytics. But a lot of the artificial intelligence applications out there at the moment are all about pattern recognition, or rather observing change. And that's why I think artificial intelligence really is at the fore in terms of those particular fields. It has many other applications. Job searching, for example, and being able to use artificial intelligence to learn about the job applicant and to be able to recommend, much like Amazon does, but recommending targeted jobs based upon somebody's background or based upon new skill sets, linking it in, for example, to their profile on LinkedIn. And it goes all the way through to stock markets. So there are lots of agent-based systems, pieces of software that can start to negotiate, that can start to learn those patterns and can start to apply them. But for me, as I've said, really, I see medical applications as the real silver bullet in terms of artificial intelligence. But there are some challenges with artificial intelligence. The first one there, actually being able to represent intelligence in a way that a computer understands, and taking all of the complexity around intelligence. Because at the moment, a lot of the solutions that we have to build are intelligent, are complex, but far less complex than, as I say, the human brain and intelligence more broadly. It's also about being able to have enough data. And I think that's something that we're really reaching a tipping point at now. And in terms of data and having enough data, actually, I should be a bit more specific about having enough good quality data, because there's loads of data all around us. But at the moment, it is a needle in a haystack. Probably about 1% of the data that we collect turns out being able to be transformed usefully into information to help make decisions and to generate what I call wisdom. And of course, the other big barrier that we've got at the moment, and I don't think this is anything that we're going to be able to overcome anytime soon, but I'm more than happy to hear from others at the end, is human resistance to machine intelligence. How can a machine be intelligent? We're always being told that they're only able to follow the rules. So what happens if we really generate something? We really generate a device that is artificially intelligent in the true sense. Will people embrace that? And I guess I'd point to things like assisted living and robotics. There are advances there now, but there's still that hesitation. It's still not quite the same as talking to a human. There's still that edge to it that makes you feel a bit uncomfortable. And if you've read something like A Brave New World, you feel even more uncomfortable. And finally, it's about being real. And I don't say that artificial intelligence isn't making good decisions. But again, to give that confidence to people that it's actually real, that actually you have confidence that the decision that is being made is sensible and is something that you can rely on. Because at the moment, it's quite difficult in most solutions to determine, or rather it's quite easy to determine where a machine is making those decisions. So I think we've got to work harder on the user experience side and then plug in all the good work we're doing around the back end, as I like to term it. Okay, so why hasn't AI changed the world yet? Okay, well, there's a nice article here. I'll leave you to read it in your own time. And it really stems back to the fact that at the moment, there is still a lot of, I guess, hesitation, a lot of suspicion around what's being built. There's a lack of data. There's a lack of it being like a human. And it's not really reached the potential that was predicted in the 1970s. So back in the 1970s, artificial intelligence was going to be everywhere. It was going to take the world. Okay, we were all going to go around. We're all going to levitate. You know, any of you that are old enough to have watched the Jetsons when you were young, you know, we're all going to drive around the sky in cars. We haven't reached that mantle yet. And I guess me, for one, I'm quite glad about that. One of the biggest problems is that whilst artificial intelligence has made great strides, it's been quite hidden until fairly recently from real users. So it's not visible. You don't see very much of it. You don't see suddenly people talking about, you know, how artificial intelligence changed the world. Or at not least, we don't hear that every day. And if we do, it's probably fuddy-duddies and academics like myself, or people in research and development in organizations who pick that up and say, oh, isn't that interesting? The general public tend to kind of say, oh, yeah, that's nice. And 10 minutes later or 10 days later, it's all forgotten. And of course, one of the biggest challenges for us, predicting the future. Where's it going? The world is changing and constantly changing. So artificial intelligence needs to be able to have that adaptation. And truly, that computer needs to start to think for itself. We might give it a little nudge, but I think we need to give it less of a nudge than we're giving at the moment. But there is hope. And really, two examples here. First of all, drug development. So at the moment, drug development is quite rightly very highly regulated. And because of that high level of regulation, it takes a long time to get a drug to market, typically around about 5 years. Quite rightly so, because a lot of the drug trials that we see lead to significant side effects. And I can point, you know, most recently to COVID-19. So the work that's being done at Oxford and has now thankfully been resumed around patient trials, you know, that had to be paused. And it had to be paused because people people suffered some fairly significant side effects, some of them neurological, for example. And so the researchers really wanted to understand, was that something to do with that particular subject, or was it to do more broadly with the drug and how once it got inside the body, it started to make those physiological changes and perhaps change things in ways that hadn't, as I said before, been predicted. But we've seen examples of where drug development has been reduced from 5 years down to 12 months in a safe and effective manner. And the other area where we see artificial intelligence, autonomous vehicles. So you can go out to Milton Keynes, for example, and they've got little delivery vehicles that go around on the pavements. We've got Tesla on autonomous driving. So we have seen those examples, but what we also see with those examples are the negative news stories. You know, that the Teslas that crash, the legal cases that are brought against Tesla because somebody's been seriously injured or unfortunately been killed. However, artificial intelligence around path planning, routing, how these vehicles communicate with each other, all examples of artificial intelligence in real day life and real applications. Some examples beyond, of course, the medical domain. Amazon Alexa. I've got an Amazon Echo Dot here. So a virtual assistant that takes your voice, for example. So just before I came on, I did some voice training with Alexa so that she could start to learn my voice and start to understand me. But most importantly, those being able to utilize artificial intelligence to learn my trends. What am I interested about? So that I can not necessarily have to train it significantly. I can just give it a few tidbits and it can go away and it can use those tidbits, put it together and create a truly artificially intelligent system that's useful to us. I mentioned before Facebook and the ability to have targeted marketing there, to learn about you, to present the information. The Amazon example, Google, email, aeroplanes, the list is endless. Of course, we have to put a degree of caution here because actually some people are very worried about, okay, I talk to Alexa, I ask Alexa, how could that be used against me? So instead of it being used for good, how could it actually be used against me? Could they start to use it? And could we go towards that brave new world where things mutate, where things take on a life of our own? And I don't think as humans, at the moment at least, that we're quite ready for that. We can take a look at the rise of machines. So there's an example here of being able to 3D print your own robot and be able to use artificial intelligence. So you can start to have a conversation. And that's particularly useful in assisted care. So for example, in Japan, robots have been built. So Pepper the robot, for example, where they can go in to care homes. They can go in to somebody's home and start to strike up that conversation where perhaps that person is on their own. And that conversation, learning about the discussion. So at the moment, it tends to be the human that has to start the conversation. But wouldn't it be brilliant if actually we could utilize those machines so that those machines could start the conversation? Because let's be honest, as we all get older, there are just some days where we don't necessarily feel about striking up that conversation or starting if we're always having to start that conversation. Maybe we get a bit fed up with it. And so wouldn't it be great if it could learn about our mood and perhaps not talk to us when it knows we want to be alone, yet be able to strike up a conversation and pick up on those human emotions. And that's the real challenge. How do you know when somebody is happy? How do you know when somebody is sad? And how do you turn that from something that you and I can do as humans? How do you turn that into something a computer can recognize? So hot off the press, about 6 or 7 months old now, but artificial intelligence helping to develop a new antibiotic, looking at the disease, being able to understand that disease and being able to recommend an antibiotic that could go into production. The one thing it didn't do was it didn't do that itself. It helped design a new antibiotic. And that's the step change now that I think we need to push and need to be able to make. How can we go from using the computers to help us design a new antibiotic to giving them the data and for them to go away and be able to design that antibiotic without any human input? And you might all go, no, we can't possibly do that. I don't mean that we have to get rid of human input, but see whether the artificial intelligence can build up and develop that antibiotic. And at the end, of course, we're still, I think, for probably the next 20, 30, 40 years, going to be dependent upon that human checking, making sure, has the computer really made the right decision? Or actually has it developed something that on the face of it looks great, but potentially could cause other significant side effects? And then we had an interesting example here in 2019 of where artificial intelligence took a load of computer clips and video clips and put them together into its own TV program. I have to say, it was a little bit of a bizarre program, and you can actually watch it. This is available on BBC Click. But that was a program made entirely using artificial intelligence. So artificial intelligence, it was given a database of movie clips, and then it thought about how it should put those together. As I say, the results are interesting, but nevertheless a good first step in terms of how artificial intelligence can be applied to fields beyond chess or beyond Facebook. And of course, one of the things I've neglected so far, and apologies if we've got some avid gamers amongst us, actually artificial intelligence has been for quite a few years now incorporated into augmented reality and virtual reality games. Most of the games we play, the Halos, the strategy-based games, there is an element of artificial intelligence in there, trying to predict what that next move is going to be, trying to defeat us as the human player, or trying to learn our habits and perhaps give us some help and advice around that game world. And it's changed a lot. It's gone much more from, okay, it's very blocky and very programmatic, to actually some semblance of being artificially intelligent, some sense of being able to strike up that conversation. So again, I think in terms of AI in computer games, good progress has been made there. Of course, the classic example, so DeepMind beat Kasparov, and it's learning to play chess, not like a machine, which it's done in the past, okay, where it checks through all its rules, but actually trying to be like a human and trying to use its rules in a way that humans would use. And again, you may or may not be aware that over the last several years, DeepMind has built several of the best Go champions in the world. So I think there it has applications. But you see, what I'm pointing out here is how can we actually incorporate that human intelligence now? How can we make it seem more human? And maybe the answer is around the user experience and the human-computer interfaces that we build. And maybe it's not the artificial intelligence that's wrong. Maybe it's us as system designers and the way that we go about user interfaces when we build applications that are artificially intelligent. Okay. In fact, this was something I wrote a couple of weeks ago. So actually being able to learn about the future. So what's going to happen in 1 week's time? Okay, if we could have predicted COVID-19, I'm sure everybody would be breathing a sigh of relief if we could have put a stop to some of the things. And some of you, of course, may argue we didn't need artificial intelligence, we just need good decision makers. Okay, but I'll leave that one for us to discuss later on. But a truly fantastic advance, and one that's quite close to my heart, is around great advances in artificial intelligence in bowel cancer and how it's being used to fight bowel cancer, not just to spot the early signs. Of course, that is an important aspect of artificial intelligence, but to be able to understand how the disease mutates, how it evolves, because quite honestly, it is an absolutely devastating and debilitating disease. And anything that we can do, and I think truly artificial intelligence has a real role to play, anything that we can do there, I think will be absolutely fantastic. So AI can help, but actually more broadly, wouldn't it be great if we could start to use artificial intelligence for personalized medicine? Because whilst right back in the 1970s and 1980s, we built these knowledge-based systems that were very programmatic, they were very systematic. Actually, you know, the way in which medicine can be delivered, actually that might differ from you to I. We might be able to use artificial intelligence and supercomputers to pave the way for that personalized medicine, to incorporate that empathy, to incorporate that emotion, and actually to feel as if it's not a computer that's making those decisions, It's actually somebody who knows and understands about me. So I guess I'm going to finish by talking about what I think the future holds for artificial intelligence. I think the data we have, if we use it more intelligently, really has a good impact, and I think that will help us to understand how we can better develop artificial intelligence applications. And I truly see the health sector as the area that could really utilize and have that silver bullet for artificial intelligence. If I had a crystal ball, of course, I'd tell you whether I was right or wrong. And some of you may agree and some of you may disagree. But I think there's a real opportunity here to help us develop new therapies, to help us develop new drugs. And if nothing else, artificial intelligence is one of the 4 big challenges that's in our industrial strategy. And so I think we owe it, whether we're researchers, whether we work in corporations and in the industry, to really give artificial intelligence a go and to find that silver bullet and to develop artificially intelligent solutions that truly do make a difference and that we can truly recognize as indistinguishable between humans and computers. So am I a computer? Are you a computer? Is the device that I'm using a computer? If we can't tell, then I think we've truly cracked artificial intelligence. So I'm going to stop there. Thank you very much for listening. And of course, more than happy to be able to answer questions. Thank you.
Right. That was very insightful and thought-provoking. Thank you very much, Dr. Sant, for your presentation. It's been very intriguing, so much so that we've got loads and loads of questions coming in. So I hope you are ready to answer all of them, if not most of them.
Don't worry. If I don't, I've got Amazon Alexa.
Yes, another AI device. Right, so the first one we'll kick off with is from Mark. Mark's question is, do you think in time quantum computing will be as fundamental to AI development as the Industrial Revolution was to society?
I think that's a really good question. I think quantum computers have a real opportunity. I don't truly think that everyone fully understands them at the moment. I think they could certainly help us to do things faster, to do things more complex that we can do at the moment. So I think it has a real impact. Our real challenge at the moment almost are the restrictions around how big we can build these quantum computers, and how do we keep them cooled, and most importantly, and one of the challenges of all quantum computers is, of course, the act of observing our system actually makes the states collapse and potentially changes the answer. So I think it does have opportunity, and I really like to see it make a step forward. It's certainly made a lot more progress than the bio-inspired models, like, for example, DNA computing, that were the hype of the 1990s and the mid-1990s. But I think we have to watch this space in terms of scalability. I think that's the biggest challenge. And if we can get over the scalability challenge, then I think potentially that could have a real impact for artificial intelligence.
Thank you. Got a question here from Karen. How will healthcare professionals be supported in using this software, are you suggesting?
No, I think that's a very good question at the moment. Actually, they're supported at the moment, because actually when you go to the doctor typically looks up a database, looks at your symptoms, and then potentially prescribes things. In terms of the support for that, of course, I think it's about the user experience. And I'm not saying that these artificially intelligent systems are going to be prescribing drugs, nor do I think it's the right place for health professionals to have to learn the very technical details. I think it's about how can we build the interface that makes those decisions as user-friendly as possible. So almost presenting them with the decision, almost like Amazon Alexa, being able to ask a question of the system and getting an answer in a format that is understandable. So, that's why I picked up on this idea of user experience, because I think that really is important. The way in which we design those systems, they have to be user-friendly. They have to be easy to use. And I guess in the past, some IT practitioners have been guilty of not understanding their audience. And so I think the way in which we gather the requirements and the way in which I think we need to observe and understand the way in which health professionals make decisions, but also the way in which they are dependent upon other information for those systems and the way it's presented to them.
Brilliant, thank you. Well, that ties in nicely with a question from Chris. And his question is, do you feel that the UK government is investing properly into research and development in our universities and tech sector to keep the UK a player in the AI future?
An interesting and probably a bit of a loaded question. Are they investing enough? I think there are challenges now. I think what we have seen pre-Brexit was a very fruitful set of funding for European. So things like Framework 7, FP6, FP7, and its successor Horizon 2020. I think at the moment around the budgets that are given to UKRI and the research councils, like, for example, EPSRC, I think there is a significant gap. And I think one of the challenges, and look, there's no simple answer to this, is that at the moment, the funding is in the hands of quite a small number of universities who do lots of very good research, don't get me wrong. But I think it's quite tough for newer universities and for others potentially to tap into some of those without having very good relationships with, some of those that are perhaps those research councils might think are safe pairs of hands. I think research and development into the tech industry and the support for the tech industry, I think the money is there. I just think it's not. I don't think it's signposted, and I don't think necessarily it's advertised in quite the right way. So, for example, Innovate UK, fantastic source of funding for businesses to be business-led. Knowledge transfer partnerships, which are the mainstay of, for example, Innovate UK bids. Not all universities engage with them. Some, don't get me wrong, some are very, very good at those knowledge transfer partnerships and managing that change. But I think at the moment, there is a hole in that budget. I think there is not great signposting to some of those things. And I think, we need to give help and support, but I think we need to also make sure, okay, what's the output for this in terms of real world applications? So, there's a lot of good research that goes on. How do we then take that to market? And if research sits in universities, for example, how can we better interface where it's appropriate between universities and companies so that we can work in mutually beneficial ways, and that everybody who has a good idea and there's a good chance of success can actually tap into these resources. And I think if we can do that and increase our field, then potentially there is an opportunity for us to make bigger strides in some of those areas. And certainly if I compare what I see in the UK in terms of funding to the US, at least on the face of it, the US, the National Science Foundation and all of the funding that goes on there, and the Googles and the Silicon Valleys, I think that far outstrips what we have here in the UK. And I'm not saying for 1 minute that suddenly we're going to transform into the funding that, is in the US. But I think, how do we establish that tech sector? How do we get the startups or the established businesses, and how do we give them the confidence to bid for this money? And when they get that money, how do we make sure that whatever is produced goes to market and provides a benefit in terms of the product that somebody could use, but also to the business, and almost see that as a feedback loop and helping that business grow.
Brilliant. I think we're pressing for time. I'll just ask one more question. We've got quite a few more, but last one here is from Mark. Deepfake already uses techniques from AI and threatens the very idea of democracy. What safeguards do you believe we need to combat against that? And where do you believe they need to be applied?
Okay, yeah, no, absolutely. I think that is also a very good example of how artificial intelligence is potentially being used in the wrong way, in my view, in order to generate those fake news stories. Now, there have been some developments, and some people are generating tools that can sniff out, so to speak, those deep fake news stories. But I do agree with Mark in terms of it threatening democracy. And I think we have become very dependent upon news feeds and what we see in the media. And I think the boundaries between what is true and what is fake, they really have become very blurred. And I guess one of the successes of the artificial intelligence techniques, at least in terms of deepfake and fake news, is actually some of the stories that are generated are very believable. And so, I think we have to educate. One of the things that I've certainly seen, obviously, the great things to do with social media, great things to do with the growth of the internet, and we've come a long, long way in a relatively short period of time. 1994, people were, amazed with dial-up of 27.7K. But I don't think we've kept pace as humans with the development, and so we've become so used to having that information all around us that we don't necessarily stop and listen and think for a second. And I think there is that culture of, oh, that looks real. How many people can I spread it to? So, Facebook, go and spread everything to your friends, and suddenly fake news becomes reality. And there have been some real worrying examples of that. So I don't think there's any easy answer to that, other than how do we educate users to be careful about what they read and not spread it, so that you don't, something from folklore suddenly becomes fact. And at the same time, not inhibit users' opportunities for be able to widen the sources from which they get their information.
Thank you very much, Dr. Sant. Unfortunately, time has caught up with us. I'll make it 8 p.m. now. Just before we close, I'd just like to mention a few things in relation to our forthcoming event, which is the Ada Lovelace Lecture, which is taking place on the 13th of October, 7 p.m. And the title of that event is Diversity in IT, Why It Matters. The speaker on the night will be Joanna Smith. She's the Chief Information Officer at Great Ormond Street Hospital. And Joanna will be having a light-hearted talk, and look back at her career in IT and her thoughts on why diversity is so important, and what more can be done or should be done to take women from being 20% of the technology workforce up to 50%. More information can be found at hats.bcs.org or any of our social media platforms. Once again, Dr. Sant, I just want to thank you very, very much for your time and insightful discussion about AI. I know it's left me with a few questions, especially with my security hat on, but as you said, it's something that we need to work on, discuss, and do a lot of work around awareness to the public and everyone else involved in this field. So thank you very much for your time. Thank you very much all that have joined on this live link, and wish you all a pleasant evening. Good night.
Thanks, Ron. And I'm more than happy to take questions if you need to field me them in and then feed them back into the BCS.
We'll do that. Thank you very much for your time.
Thank you.
Good night, everyone.